So today we're going to review our two main types of bonds, ionic and covalent bonds, and then we're really going to focus on covalent bonds and two different types of covalent bonds, which are polar or nonpolar. So I want to start with the question, what is the difference between an ionic bond and a covalent bond? And when I ask what's the difference, it's really what are the electrons doing that's differently? So in an ionic bond, electrons are being taken or stolen. So like one atom takes the electrons from another atom. And in a covalent bond, the electrons are being shared. So they both share their electrons to get that filled octet. So today we're going to really focus on covalent bonds. So in a covalent bond, the electrons are shared. Okay. So here we have these two atoms. Okay. And if you notice, they're going to share some of their electrons here so they can both have a filled octet. So as we look at different covalent bonds, I want to use the analogy of tug-of-war. So in the way if you were going to play tug-of-war, you would share a rope with your opponent. Atoms are going to share these electrons in their valence shell. Okay. So our two types of covalent bonds are either nonpolar covalent bonds and then polar covalent bonds. So today we're going to learn what is the difference between a nonpolar and a polar covalent bond. And then if I'm looking at two different atoms, how can you tell which type of bond will form? So first we're going to talk about nonpolar bonds. So in a nonpolar bond, the electrons are going to be shared equally. So if we think back to the game of tug-of-war, this would be like playing tug-of-war with yourself or someone who is equally as strong as you. Okay. If I play tug-of-war with someone who's exactly as strong as me, that rope isn't going to move, right? We're going to pull it at equal strengths and it's just going to stay there. The same thing is happening with these atoms with their electrons. So if they're pulling the electrons with the same strength, then the electrons are just going to be evenly spread out throughout them. And so atoms, they don't actually have muscles and pull, but what they do have is electronegativity. So electronegativity is basically electron greediness. So when two atoms bond, which one's going to pull the electrons closer? And so the way we can tell if a nonpolar bond is going to form, we look at the two atoms that are forming the bond, and we look at the difference in their electronegativity values. And so if that difference falls between 0 and 0.4, we know it's going to form a nonpolar bond. All right, so then another way you can write this to shorten your notes, we can use delta and En for electronegativity, and it needs to fall between 0 and 0.4. Another time is if atoms are the same. Okay, so such as like H2. If it's hydrogen bonded to hydrogen, they're identical. So of course the electronegativity is going to be 0. Same thing for O2, oxygen bonding to oxygen, and N2 is N bonded to N. Okay. Our second type of covalent bond is a polar covalent bond. So polar bonds form when the electrons are shared unequally. So this time, if we go back to the tug-of-war example, one of the atoms is winning the game of tug-of-war, and the other atom is losing the game of tug-of-war. And again, instead of a rope, it's actually electrons being pulled. So the atom that is winning the game of tug-of-war is going to pull more electrons towards it. And the atom that's losing the game of tug-of-war is going to lose those electrons a little bit, and they're going to move closer to the other atom. So then the atom with the stronger electronegativity is going to be the one that gets the slightly negative charge. And that's because this is the one, you could think of it as the one that's winning. Okay, so it's winning the game of tug-of-war. It's pulling the electrons near it. And what kind of charge do electrons have? Negative. So since it's pulling more negative charges to it, it gets that slight negative charge. So then that means the less electronegative atom is getting a slight positive charge. So this atom, it's losing the game of tug-of-war. So its electrons are moving further from it, okay, which is giving it this slight positive charge. Okay. So I'm just going to say electrons are moving away. All right, so then how we tell what type of bond is going to be formed. Okay, so we look at the difference in electronegativity values, and by difference, you're just going to subtract, and you always subtract the larger value minus the smaller value. And so if you get a difference that is 2 or higher, then it's going to be a full-on ionic bond. Okay, so it's like when you play tug of war and one side actually lets go of the rope. Okay, so that would make the ionic bond. If the difference in electronegativity falls between 1 and 1.7, it'll be a polar covalent bond, and this one's like really polar. If you get a value of 0.41 to 1, it's a polar covalent bond, but just moderately polar. However, you can combine these. So really, anywhere from 0.41 to 1.7 is just going to be polar. And then finally, if your value is between 0 and 0.4, it's going to make a non-polar covalent bond. So make sure you have this scale written down in your notes. And then if you look at this, there's kind of this gray area between 1.7 and 2. Okay, and so this is kind of fuzzy. It's definitely strong polar. It might even be ionic at this point. So the rule of thumb is if you're in this gray area, if you have a metal and a nonmetal, you will call it an ionic compound. And if you have two nonmetals, you will call it a covalent compound. And if you call it a covalent compound, of course, it'll be polar covalent. Okay, so we're going to do an example together. So we're going to look at HCl. So you would look at a chart, and you would just look up that hydrogen has an electronegativity of 2.1, and then chlorine has an electronegativity of 3.0. And so we need to find the difference of these electronegativities. So you're going to take the larger number and subtract the smaller number. So 3.0 minus 2.1 is going to equal 0.9. Okay. And then we just look at the scale, and 0.9 falls in the range of polar. Okay, so HCl is going to form a polar bond. And then how do you know which side is going to be the positive or the negative? Okay. Well, the more electronegative one is going to get the negative. Okay, so here the chlorine, it wins the game of tug of war, so it has more negative charges near it. So that means the less electronegative atom is losing the game of tug of war, and it has that slightly positive charge to it. All right, one more example is water. So again, you would just look up a chart. Hydrogen is 2.1, and oxygen is 3.5. And you just find the difference in electronegativity. So we take 3.5 minus 2.1, and that's going to give us a value of 1.4. So again, 1.4 falls in the polar range. And then how you know which one's which is oxygen is the higher value. So oxygen gets that negative charge. Hydrogen is the lesser value, so it gets the positive charge. Okay. So then one of these bonds is polar. We could do the same thing for this bond, and since they're the same atoms, we get the same value. So again, oxygen is negative, hydrogen is positive.